Remember, we were asked to calculate the axial force, axial load on this cross section. So our M becomes Fc plus Fs2 minus Fs1. I'm subtracting the Fs1 because, as you remember, it was acting in the opposite direction as with the Fc and Fs2. So this will be summed up and Fs1 will be subtracted from those. And going into the values that we have got, Fc was 590.6 plus Fs2 was 244.8 minus Fs1 was 252 kilonewtons. So the answer would be 583.4. 583.4 kilonewtons. So this is the axial force, axial load on the cross section. This is the axial load on the cross section, and we have calculated that. Let's move on. At the beginning, we were also asked to calculate the moments in the cross section. So what I'm going to do to get the moment, I'm going to take the moments about the centroidal axis, which is here, which is named as the neutral depth. This distance, let's write it as neutral axis. Okay, this is our neutral axis. So I'm going to take the moment of the forces with respect to this neutral axis. Which forces? Of course, Fs1, Fs2, and Fc, the three forces that we have in our structure. So let's do that. Express our moment one by one. So our moment will be equal to Fc times the force in the concrete layer times the moment arm. So what will be the moment arm? H over 2 minus K1C over 2. Why? Because we know that this distance from here to here is equal to H over 2 minus K1C over 2. This is the distance that we are looking for. And for the steel layer number 1, the force in the number 1 times H over 2 minus 35. 35 was the clear cover depth. Clear cover depth, which was given at the beginning of the question. Both here and here, they are the same for both the steel layer number 1 and steel layer number 2. So I'm going to use 35 for each of those. And for the Fs2, the moment arm would be the same, H over 2 minus 35. So let's plug those in. Our Fc from the previous pages, 590.6 kilonewton. H was 500 divided by 2.85, 109 divided by 2, plus our Fs1 was 252 kilonewtons. 252, and the moment arm would be 500 divided by 2 minus 35, plus Fs2 was from the previous parts 244.8 times the moment arm will be the same as the Fs1, which is 500 divided by 2 minus 35. So again, I've taken the moments about the centroidal axis. And I recommend you to do that in the questions that you encounter. It is the simplest way to get the moment acting on the system. So let's plug and check those values into our calculator. I'm gonna ask for a little bit of time to get those values into my calculator. So at the end, the moment that we get is 227.1 kilonewton times meter. So this is the moment acting on the system, and this 583.4 kilonewton is the axial load on the cross section. And those were all that we were asked in this question.